The great Galileo Galilei was the first to observe the wonderful rings of Saturn in 1610. Since then, our understandings of the inner workings of our solar system and the destructive processes that created these celestial bodies in the sky has drastically grown. So how did Saturn's rings get there, and what exactly are they? Welcome to the Daily Galactic. Today we're talking about one of the wonders of our solar system, the beautiful rings of Saturn. The age of these phenomenal feats of nature have been a long debated topic, with estimated ages varying drastically. Some suggest that they're extremely old and date back to the formation of Saturn itself. However, data from the Cassini spacecraft suggests that they are much younger than we previously thought. Based on modelling of the rings' dynamical evolution and measurements of the flux of interplanetary dust, they're believed to be between 10 million and 100 million years old. Saturn's rings are constantly losing material and are estimated to completely disappear in about 300 million years. But what happened all those millions of years ago to create such a unique cosmic feature? There are two main theories floating around the scientific community at present. Make sure to watch all the way to the end to hear them both, and let me know which one you think is the most likely cause of Saturn's rings. The original theory, proposed by French astronomer Edouard Roche in the 19th century, suggests that the rings are remnants of an ancient moon of Saturn. This moon is called Veritas, whose orbit decayed and moved closer and closer to Saturn until it was eventually ripped apart by the powerful tidal forces of the planet. Called the disrupted moon theory, it takes into consideration a celestial mechanics term known as the Roche limit, named after the previously mentioned French astronomer. In short, it's the distance from a celestial body, in this case Saturn, that a second celestial body like Veritas, which is held together by its own gravity, will disintegrate due to the larger body's tidal forces, which are much more powerful than the smaller object's own gravity. Inside of the Roche limit, objects find themselves being dispersed and broken apart to eventually form rings. An example of this, which we have observed in recent years, is comet Shoemaker-Levy 9. Pictured here by the Hubble Space Telescope, in 1992 the strong tidal forces of Jupiter disintegrated this object into a string of smaller bodies, before eventually they collided with the planet in 1994. The second theory that astronomers debate is that the rings are made of debris from a moon slightly larger than Mimas, that was blown to pieces from multiple bombardments. This most likely happened during a period in the solar system's evolution called the Late Heavy Bombardment, about 4 billion years ago. But a more modern variant of this theory by American astrophysicist Robin M. Canup is that the rings could be leftovers of the icy mantle of a much larger differentiated moon of a similar size to Titan. The icy crust would have been stripped away from the core of the moon as the rest of it plummeted down into Saturn's atmosphere, during the time when Saturn was forming and it was surrounded by a gaseous nebula. This explains quite well the lack of rocky material within the rings, as they're primarily made of forms of ice. At this time, the rings would have been much more massive and far broader, with predictions saying that they were about 1,000 times more massive than the present day. With a large amount of material in existence around Saturn, in the outer rings the material would have coalesced to form Saturn's modern moons all the way out to Tethys. This also explains how the majority of Saturn's moons are extensively lacking in rocky material and are primarily made of ice. This idea of Saturn's early massive rings was subsequently extended to explain the formation of moons all the way out to Rhea. If these massive rings also contain chunks of rocky material as well as ice, these silicate bodies would have accumulated more ice and eventually would have been expelled from the ring system due to gravitational interactions with the rings and Saturn itself, which in turn caused progressively wider orbits. Once outside of the ring system, these moons could have continued their evolution from consequent mergers and impacts to form the outer moons of Saturn that are there today. This long-winded process could potentially explain the variation in silicate content of the outer moons, as well as the recognised trend of moons having less silicate content the closer they get to Saturn. If this is the case, Rhea would be the oldest of Saturn's moons formed from the rings, with the moons also getting progressively younger the closer they get to Saturn. So these are the two main theories of where Saturn's rings come from, but both aren't without holes in their theories, as research based on rates of material from the rings falling into Saturn favours a younger ring system that came into existence much longer after Saturn did, which contradicts the icy mantle theory. Which one of the two theories do you think is correct? Is it the disintegration of a moon passing the Roche limit, or the loss of an ancient moon's icy mantle that created the smaller outer moons of Saturn? Let me know in the comments below, and as always, thanks for watching all the way to the end. Make sure to leave a like if you enjoyed and subscribe for more content every week. See you soon.